are dealing with the information or the data. So I think the most of the time when I offer the advanced or just the database design, I like to talk about what is the information, what is the data, and what is the computer science also. So information is usually the everything. Okay, like even the young kids and human beings, they try to get the information, then get the experience and decide something. So, for example, when you recognize something object, right? This is a chair. So nobody talk about this is a chair. But I know that because I already got enough information throughout in my life what is a chair. So we can get the concept of such an information. That is the information. Then from such an information, we'd like to collect the specific information. Okay, in the too many such specific information in the computer system, which means we need to organize such an information. Information are everywhere and everything. They are not organized, sometimes not visible, not the structure, but the data in the system, especially for the computer system, it should be organized. Why? Because due to the nature of computer science, computer can understand only structured data. In other words, it's formatted data. So that is called the data. If we have a bunch of such a data, it's called the database. Then to build such a database, we need to have certain rule, okay, or constraint. That is the database model. Okay, so we learned such a database model, for example, relational model. Then, based on that, we learned about the, for example, relational database model, and after implementing such a relational database model, it will be relational database management system. Using such a relational database management system, such as Oracle Information DB to MySQL, whatever, then we can manage and manipulate the data. Okay, so that is the current situation, how we can manage and organize and manipulate such a data. So far, even right now, majority of such a managing the data is based on the relational database model. Relational database model is not the only data model. There are a bunch of other hierarchical data model, object-oriented database model, and so on. So, but anyways, so that's the current history. However, we have learned about the header for big data system. What is the problem of using such a relational database model or the database model to manage the data? First, is too specific or the too strong constraint. Okay, in other words, it's not flexible. For example, to keep the customer information, we need to clearly define what kind of attribute, in other words, what kind of column we need to collect. So we need a customer ID. Even customer ID should be 10-digit number. Okay, it's very strong. Who knows? Somebody has a different ID, somebody has a different name, very long name, 100 byte word. Sometimes there's no information about the phone number, but even though I do not have the phone number, we need to specify, we need to have something information about the phone number for customer table. That is not data sometimes. Okay, looks like that. So it's too much constraint. It's not flexible. Another problem of using such a relational database model is it can handle very nice work for the online transaction processing system, like the banking system or the stock market trading system. Usually OLTP require very short response time. Okay, so it's good for such a online transaction processing system. However, when you have the big data like a petabyte, several petabyte or exabyte, which is usually happen in the social media data, actually such a petabyte size data is not working very well on top of the relational database model. So Google already realized such a problem. That's the reason they even proposed a new idea of the file system, which is the GFS that you already learned. And also, because the file system are changing, they need a different processing. We try to get the benefit of such a Google file system, HDFS, it's a map-reduced programming. Also, anyway, eventually we try to manage such a big data as a database data. Okay? But they already realized the traditional approach. That's what we do such a big data. Big data usually several petabyte size data and even much bigger such a data. So to do that, we need to different approach. That is called NoSQL database. This is not the opposite of the relational database model. It's another approach to manage, to organize, to manipulate the database. Okay? So this is the NoSQL database. Somebody said it's not opposite. NoSQL negative is not only the SQL. So we are going to discuss about such a NoSQL database for the Hadoop system today. The first problem is the scale of the size of the data. The when relational database has the several terabyte, one less than the petabyte size, so their performance is like that, and even drop the performance when you have the bigger size of the data. We need to address such a problem. Whenever you have the bigger size of the data, so many people easily suggest why don't you scale up. So when you have the number of nodes, more number of nodes and performance, everybody expects such a the performance and linearly increase performance, but that's not true. Okay? Sometimes when you have the more number of nodes, it's more complex and performance is downgraded. So scale up is not working very well in traditional approaches such as relational database, and also there uses the scale up approach in traditional database management system like the parallel database and distributed database. But their performance is not acceptable, so we need a different approach. In such a traditional approach, we can classify into two. One is a master-slave approach, and another one is a sharding approach. Master-slave approach, you have the first you write the data to the master, and then master distributes such a data to the slave. So slave data is dependent on the master node. Okay. Anyway, since the master node write the data first and distribute such a data to the slave, so when you have the large data, it should be multiple copies and it's slower, so it causes the problem. So another approach is the sharding, in other words, partition based. So you can partition, for example, the big data into several parts, and this part is a separate node, this part is a separate node, this part is a separate node. This one is working well when you have the specific business logic. Like this is for January, February, March, and all application access only January, only specific the month only. Okay. However, if you need to access some of the data here, some of the randomly access the data, anyway, you need to access all the nodes. Also, in case you need to join some other sharding data or partition data, and this is a transaction, this is a customer, is very complicated. Okay. So, yes.
I think it's also related to the same problems because the structure of the Hadoop system is working as master and slaves.
Yes.
Even though we have different.
So that is a reason Hadoop support cannot cover entire traditional system, part of the traditional system. Okay?
You don't write anything to the master.
So that's the common mistake, the illusion of the using Hadoop. Hadoop is not general solution. It's a very specific problem of the sharding approach in the traditional scaling of the relational database management system. Okay. Also, there are approaches to support such a materialized view is another thing. For example, in relational database model, for example, this is the United States, this is New York. So New York has the database system for customers. And there are a lot of transactions in California. If you have a centralized system, they need to access all the transactions goes to this one. So why don't we separate this and make the copy of this one? However, you need to synchronize them. Okay? So if the data is inserted, they should know. So how to build such a synchronized database? At the time, you can use the view, but this is not the real view. It's a materialized view. Materialized view is kind of view, but it has the data synchronized with the master. Okay. But anyway, this one requires some data transfer. Depending on how often you synchronize, sometimes you may lose the data. Also, if you frequently synchronize the data, it's too much overhead. So it's not the general solution. Also, to speed up the database, in case this one is slow and you have the big data is slow, you can consider some the in-memory database, which is very popular nowadays. In the database, not all the data are accessed by the application or user, only less than 10% are used in general. Think about your system or even your laptop. Think about how many files do you access every day? Only several, right? So, but think about, check your utilization. You have the, for example, 100 gigabyte data. Do you access all 100 gigabyte data? Only few of them, less than 1% I believe. That's true in any application. So,
but it's going to be different from the other databases.
in other databases, so in general, it's true. Many of the data are raw data, historical data, which means so only in specific condition you try to access such data. Think about your banking statement. Do you check every time, every day, the year-over transaction? No, never, never. So that's the truth. Only less than 10% data are accessed. What if we put this data into memory? This is the idea of a memory database. So they are frequently used, but still there are problems of using such an in-memory database. Physically, it's not very complicated how to preserve. Yes?
It looks like the same idea in the operating systems.
Yes.
Some files has been used many
But
times.
in database, you need to keep the consistency, even though you lose the power how to keep such a data. So at the time for in-memory database, you do not use the general memory systems. You can use some solid state data, the disk for such an in-memory database. However, still, in terms of the data structure, you can speed up the performance of your system and the denormalization. So one of the expensive operation in relational database model, probably I mentioned many times, join operation. To join two tables, it looks like very nice and easy to use. However, you need to access the entire table or one table and another table. Also, you should have a memory to keep the matched data. So join operation is one of the expensive operation, so that slow down your overall performance. How can avoid such a thing? You can denormalize, which means so join is kind of separate by the user, by the color, by the gender, whatever. So in this room we put only the man with the white hair, and another room the black hair, and another room is a female, only for wearing scarf, whatever. Then to combine, you need to visit each room, and you should have the separate room to match them. Okay? instead of such approach, why don't we put all students in one room? It's a denormalization. It's to avoid actually violate the rule of relational database model, but you can speed up. So sometimes you can use such approach.
But if it's too big, you cannot. Because they're not big.
Too big, you can do that, but the problem is in your application you need to check the consistency.
Yeah, consistent.
So to address that problem, we need to think about the different approach for database management issues. So which is called the NoSQL. Okay, NoSQL is kind of the relaxed. Okay, the relational database model. One of the problems of the relational database model is too strong constraint, too much condition. It's not flexible. So why don't we consider opposite way? It's the relaxed data structure.
Excuse me, Professor, but this condition is, it's dependent on the asking, I mean, the queries that we want. So, why do you say that it's, we can release some conditions, but it's dependent on the users or
Then-
what ones want.
If you want to ignore such a condition, why don't you use, why do you need to use the relational database? You don't have to use the relational database. Because that is the reason why we use the relational database. Because it has a very strong rule, very strong the format, organization used by following that rule. It's easy to use, easy to maintain the data consistency.
Right.
You don't have to worry after you create the primary key. You don't have to worry about whether this is the duplicated ID one because DBM has changed. But if you disable the primary key, you need to decide to either ignore primary key. At that time, you don't have to use the relational database. Or you need to check the primary key in your application program. It's very, very expensive. Right? So that is the nature of the relational model. Because it has too much constraint. It's a simple to use, but it has a very, very tight the rule. So why don't we make it relaxed? Okay? One, which means we give up certain condition as you suggest. That is the NoSQL database approach. So when we talk about that is called the cat error. C indicate the consistency. Data consistency is very important. Like the rule, whether primary key, foreign key, so consistency and availability. Whether system is, even though the unplug the power, system still keep the data, update data. For example, simple example is when you update the data, this is the computer and DBMS, and this is the data. So you have the 1, and you update the 1 to 2 and commit it. But as I mentioned many times in my database course, 2 will not be applied to the database. Okay, directly. It's a default writing. Why? For speeding up. Writing a data hard disk drive is very, very slow. So you just update in the memory. What if this memory is gone? You lose the updated data. That's violate the data availability. Then how can we keep it? So at that time we can use the write ahead log. So you can use the log information to redo. Okay? You learned about such a transaction control in the database design. At that time we give up such a availability. Okay? And P. What is the P? Partition tolerance. Partition tolerance is eventually in our solution anyway we need to use the multiple node. Okay? It can be partition or whatever. So at the time, what if one of them is crashed? In partition approach, sharding approach, if you lose the one of this one, you may lose the January data. Okay? Even though you still have the February, March, and the other, you cannot use this data. In our new approach, the P part tolerance means that even though you lose one of this, The other should be better. The partially tolerable system. So this is called the CAP theorem. Relational database model support all these the characteristic, which means it's too much control, too much the condition. Okay. So in NoSQL database, we are going to give up one of these. Okay. For example, we keep the partition tolerable and should be available anytime. Okay. However, we give up the consistency, which means we cannot guarantee the primary key or something like that. Or we can keep the consistency and availability, but give up the partition tolerable, something like that. That is the approach of the NoSQL database model. We will see details about it.
When you say that if we lose some nodes, something like that, we will lose like maybe everybody
So
information.
we will see details about it.
But I'm just confused because it's like against the structures of the heavy file system.
It's not hybrid file system. In traditional file system, for example, this is a traditional approach, the partition table. There's a way to create the table that are partitioned by something. It can be hash partition, it can be partition by condition, and so on. But in that case, if you lose part of that, what it is? So there, before we learn about such an example of the, before we learn about the NoSQL database, there's no one general data structure. Okay, each and every DBMS has different characteristic, different data structure. But roughly, we can say they do not keep all these the characteristic, but they give up one of these. Okay. The Facebook, Twitter, and Amazon. In Amazon, there it is the Dynamo or whatever, or the HBase that we are going to learn. So they are the example of such a NoSQL database. For example, Dynamo and the table is from the Google file system, Google. So that is the third, the reading assignment. It's actually the father of HBase database. But forget about the idea of relational database model. It's different from, even totally different from the relational database model. However, many of the people already learned about the relational database model. They usually compare with relational database model with the NoSQL database. Then the most frequent asked question is like, what is this in the HBase? For example, the join, what is a join? What is a this? What is a this? So, usually in the relational database model, it's different data structure, different approach. Okay? They try to, however, because many users are still on the relational database model, so we try to build the NoSQL database that are similar as the relational database model. However, they are different facts. Okay? So even sometimes it helps. Forget about everything of the relational database to understand NoSQL database. Okay? So to understand such a concept of the NoSQL, this is a reading assignment. So if you have a time, why don't you find a paper from Amazon? Amazon has their own the NoSQL database. NoSQL database is kind of the flexible database model. Okay? So first is a good starting point to understand the CAP theorem. The consistency. Consistency is the same as what you know learned in the database design. availability, and partition tolerance. So we will see each of them. So consistency means the data consistency. Okay. So once writer has written, then all when the writer commit, when you insert the data, then committed, all the other user should be able to see such a change in data. However, for example, the Facebook, even though you post the data, post the message, not all users can see your posted message. Sometimes it takes time. Even though right now I'm a god, so I know that exactly how many people click the like, that is for example 10,001. But in the system, it can be shown as the 9,900. Some user can see only the 10,001, or the other user can see different. Okay? There's no guarantee to see. If you need to guarantee exact number, simply it's overhead, right? To synchronize all the server data will have the different server, and so that they try to not give up all consistency, loosely the support such a consistency. That is the consistency. However, the relational database model is very strict. The consistency is the most important one. Like to think about the banking system. Okay, if somebody deposit the money, but I cannot use that money, that's a problem. And stock market system is more serious problem in stock market trading system. I like to purchase the stock to buy 10, but somebody the 12, but it's not applied, no guarantee, then that will be the problem. Okay, that is a consistency. Okay. There are two kinds of consistency. One we already learned in the advanced database design is called the ACID. So let's take a look at briefly about the ACID. Atomic. Atomic is each process is one database transaction cannot be divided into two. It's all the transaction has begin and end. There's no in the middle, no part of commit. So until transaction is ended, it will not be applied to other. Even you change the data in the middle, but your transaction is aborted by the network problem or whatever, then all the changed data should be go back, something like that. So one transaction should be atomic, that is called atomic. Okay? I think in your operating system class you learned about the critical solution problem. That is the same problem as the atomic. So to address the critical solution problem, so you can use many of the operating system, use the transaction concept. Then C stands for the consistent database constraint are preserved. So which means there's one state of the database. If somebody change the data, update the data, if database is read-only, there's no problem for consistency, right? It's always the same state, right? However, the database allows changing the data. So once the database has one state of the data, then modify. It's moved to another state of the data. That should be preserved. That is called consistency. Isolate is when a data is executed, modified. It should be isolated. So one is changing to not is before commit. So the other user will see only one. So before data, because it's not coming. But this user will see changing data too, because it's isolated. So that is called the isolation of the execution, in other words, transaction. Then the last one is a durable. If system, even though system is crashed, it should be preserved using the raw data like the right header. So you learned about the redo process and undo process. Redo is so do it again. Even though system question if that is committed. So you need to do again. Undo means should not been applied, but it's applied. So you need to go back. It's the undo process. So this is ACID of transaction. I'm not very good at base, basically available to state the eventual consistency. I don't understand exactly what eventual consistency, but what I understand is you consider the time, okay? So if the database state is not being changed for a while, it will be applied. So certain the database consistency, okay? So it's a propagate. It's the relax of the ACID is when the moment when the data is changing and committed, it should be applied to the everyone. But this one, eventual consistency is if not changed, it's the propagate to the other. Okay? So a little bit relaxed then along the time. But still it's a constant. Facebook is kind of the base, eventual the consistency. Doesn't give up the consistency, but eventually is applied. So then next one is availability. System is available with the software and hardware failure or the node failure. So system should be available. Okay? To support this one should be multiple nodes definitely. And also backup or copy of the data structure. For example, Hadoop system, you have the multiple copy. Using this idea, it can support availability. And partition tolerance, the system can continue to operate in the presence of the network partition or some part of the failure. Okay? So cap theorem means, so you can have at most, so you cannot have all of this. If you wanna preserve all of this, it will be relational data, traditional database model. Okay, more strict the model. So if you wanna handle such a big data with the nice performance, higher performance, you need to give up one of these. So in other words, you can have the at most two of these function. If you want to build a shared data system, okay, yes?
But Hadoop is there for
Hadoop is not actually a database model. Okay? It's not, it's fine. So, but consistency is not a problem. Why? It does not allow update. Okay? So that's the next one. Then support availability and partition.
You can use like big table and HBase for Hadoop, right? You can use them.
So HBase is kind of the preserve the consistency and availability, the nature of this one.
So you can integrate it with Hadoop, HBase and
HBase is kind of the database system, but for the file, so we will see HBase, the concept of the HBase. So what kinds of the NoSQL we have? So first, we can classify the NoSQL database into two. One is the key value, the data structure. Why? Because I had to support the key value in map reduce, right? So that is the reason the key value approach is Amazon Dynamo is a NoSQL database that I never heard about this one. The other, so Amazon Dynamo is one of the well known. And schema list is more popular. Schema list means how can you build a relational database model? You need to design by following relational model In other words, you should have database schema.
Yeah.
Customer, employee, and the relation, foreign key, the primary key, and so on. It's called schema.
Yeah,
Schema is the description of your database. Schema list means it's not entirely no schema, it's just relaxed. Okay? So sometimes it has just defined customer. There's no attribute. Customer set, column set, customer column set. Then depending on the data, there exists something. Also, think about the web page. I'd like to keep the web page in my database system. Using relational database, how can you?
You have to define everything, all the basic questions.
So what can be the key, primary key of your web page?
They are
URL. But every day you change the website, right? How can you? So
don't count.
you need to increase the primary key by adding the date, time, or whatever. So in NoSQL database, it can also support version, okay, along the time.
Version of time
Version.
stamp.
Yes, it can support such a. And column, what can be the column of your web page? You add a new information project in Crash website. Do you need to create the column? In traditional database, you need to create
Yeah, you
a
have
column.
to in advance.
If you remove that information, you need to drop that column.
Yes.
It's not easy in the relational database. So in the schema list, it can be changed. It depends on the data. Okay, so that is called the schema list.
So it depends on the
So
data.
some of them are focused on document, like the web page. Some of them are focusing on the graph. Why is graph? Suddenly, graph appears. Actually, who proposed the HDFS or the Matthews programming? School. Okay. Then Yahoo used such a thing. Facebook used such a thing. Then, what is the characteristic of the such a thing? It's a network, social network. So all data in the social media site can be represented by something network information. Okay? It's a graph. So we can use such a graph structure as a graph based database. So Cassandra is a column based database. On the other hand, relational database is kind of row based approach. I mentioned always in the database class, the Oracle information, traditional relational database management system. Actually, before that, relational model. What is the definition of a relation? A set of
Relation.
data, or row, or tuples, set of data, or set of columns, or attribute. So you can see a relation table as data, or you can see data as a set of columns. Okay, either of them. However, traditional database have you design number of column. So sometimes 100, sometimes 10 or 5 column, bunch of data. Then our focus is on how to get specific data very fast. It's a row data based data or the rule based approach. The most of the commercial relational database is the rule based this way. So it's the main priority is how we can access the data by tuple, by row, fast. That's the reason we need the index. Okay? However, this is another way. Think about the sensor data. I deploy 1 million of sensor to get the temperature of the United States. Okay? Then I like to keep record their transfer data. What is the column? Sensor 1, sensor 2, how many sensors? 1 million sensors, 1 million of column. possible. Also, data is sending the center data every time, every minute. So, in 1 hour, how many? So 24 times 600, roughly 1,000 data. Then refresh every day. This is more. This table has more columns than the number of rows. Okay, this is column based. There are many examples of the column based. Okay, so to support such a thing, Cassandra, CouchDB, MongoDB especially for the document based, and the Neo4j, the graph based, and H based is also column based.
What is the difference with
Document to manage the document, like a web page.
So documents.
Yes. So key value format is very fast because it's a similar data structure as HDFS. However, the problem is not all the database fit to the key value format. Schema list is more flexible, so you show that the key value there, and it's an eventual consistency, and many are distributed, okay? But it cannot support the whole ACI transition or join condition. Because we cannot guarantee specific column. So no join or the such a ACI. So the benefit of using such a NoSQL database is cheap, easy to implement because it's open source, and data can be into multiple nodes because so multiple nodes. Think about the HDFS, and it doesn't require or there is a flexible for the schema, and also it can scale up and down. However, to use such a NoSQL database or schema list or the key value join, you need to give up. So there's another way to replace a join operation. Okay, and group by require sorting. Order by requires sorting. To sort the data, 1 million, 10 million, so it's not good for your performance. And ACID transaction, in other words, consistency. Okay. SQL is only for relational database. However, everybody loves the SQL because it's easy and very straightforward. So we don't want to give up the user interface. So we can model the SQL idea as a user interface. Okay? So big table HBase is support the consistency and partition tolerance. So this is the data model of the HBase. Okay. So for example, when we hit the web pages, it opposite www.cnn.com because .com is the category and specific name. So we use this kind of the key. It's not primary key in terms of the relational database model, but if you cannot easily understand first time for this kind of new data model, you can consider regard this one as a primary. Okay, this is a key, but this is an operating way. Then it has some contents. Okay, it's defined on the set of family of column. Family of column, it means the header in web page. When you have a web page, you group. This is a header information. This is a script information. This is contents information. This is the images, a tag information. You just group. You don't know how many contents in this the web page. You don't know how many image tags in this and whatever. So you can just define the group column family, which is called a column family. Depending on data, you can add more column. Okay? You can ignore sometimes column. So that is the new data model. So this when indexed by the low key is this one. Even each column has the key. You because it's a set of columns. Or even it has a version of the data, like this is the state, this is yesterday, this is the day before.
So, Professor, just think what the content and the second column, they are not related to each other?
They are the same web page, but different version.
Oh,
Okay. So this is the rows, but for the column, it has the kind of family, group of column. So when you read the third reading assignment, you can understand the Google part, the big table concept. That is the kind of the original idea of the H-base. That is called the big table. Then H-base. So go to 1 minute. So in the header system, we have no. So we have the HDFS. In HDFS, we have the volume order in the file that transfer from the relational database. So we try to use, so we have the order file. That doesn't mean that this file is a database or table, okay? But we want to get the benefit of the database system, which means manage the data or some others. So at that time, is there any way to consider this HDFS file as the kind of table, okay? In terms of the database concept. So that is the H-base that can support some key concept. Even though this one does not have any key. Key value is from MapReduce column. Okay? There's no key, there's no value, but in using MapReduce, you define this is a key, offset is a key, or there's some, the ID is a key, something like that. So, is there any way to consider all the HDFS file as the contents of the database system? That is the idea of the H-base. Okay? It's a column-based database. Okay? As I explained here. So, benefit of using the H-base is the distributed storage. One, it uses HDFS. Okay? And it looks like a table. Okay? In HDFS file, there's no concept of a table. Okay? So it's hard to design, and you need to find, manually you need to define this column or this information as the key, and the others are values. If you need to access the check, you need to do the MapReduce. So anyway, yes, that is the H-base.
So the blocks will be like this or like this? The
Block?
HT we have to distribute the H-base.
The H-base use the HDFS file structure.
Exactly.
Yes. Definitely, it's a high scalability and availability and the performance because it's based on the HDFS. So, however, H-base is not the real, it's not the relational database model. Do not compare directly with the relational database model. No join operation, no looking, because it's not, it has primary index. Okay? It has the looking. It's not, but as we have seen, here is one row, but it has multiple rows and multiple different data structure for each the column family, column. Okay, that's one. So it has just the low key. Doesn't mean it's the same as the low key or tuple. No, it's a kind of group of the data. Okay. However, However, HBase support the index, only the primary index for that, the low key. Okay? And also you can, the HDFS support only full table scan, serial, sequential processing. Okay? Like the math program. So it supports the full table scan. However, HBase can support the range scan by region. What is a region? I will show you, then you can easily understand why it can be range scan. And also, because it supports only one index, so using that index, you can first look up the low key and optional
How
columns.
is the difference between the columns? You only apply the row key. How
Row
is the difference between the
Low key is the one web page is the one row.
Right.
It has a key, but in one page there are a bunch of different data structures. So each column has the also column key.
column key?
Okay.
So it uses both actually.
Yes, you need to use both of them. Also, HBase has the limited arguments